In this video, we'll go through exam questions that cover the criteria, use formulae to find volumes and surface areas of 3D shapes, including cylinders, formula to be given for 3D shapes other than cylinders. You can locate the questions on the mathsmaths.com website under Level 2. The questions come from different exam boards. We'll start with the non-calculated questions and then we'll move to the calculated questions. Here is the first one. Matt buys a new fish tank. The fish tank is in the shape of a cuboid. The diagram shows water in the tank. Matt knows 1000 cubic centimeters equals 1 litre. 1 gallons equal 4.5 litres. You can keep 2 small fish in the tank for every 2 gallons of water in the tank. Matt thinks you can keep more than 36 small fish in the tank. Is Matt correct? So we're looking to find how many gallons of water there are in the tank so that we can work out how many fish can be kept in the tank. So the first thing to do is to work out the volume. We've got these dimensions given to us, so length is 100 centimeters. We've got width and depth 30 centimeters each. So to work out the volume, we'll do 30 times 30 times 100. 30 times 30, that is 3 times 3, which is 9. Adding the 2 zeros gives us 900. So now it's 900 times 100, which means we add 2 zeros. So that gives us 90,000 cubic centimeters. We know that 1000 cubic centimeters equal 1 litre. What about 90,000? How do we get from 1000 to 90,000? We multiply by 90. 90,000. So that tells us we multiply 1000 by 90. So we'll do the same here. 1 times 90 is 90. So there are 90 litres in the tank. We need to know how many gallons of water that is so that we can use the ratio that has been given to get the number of fish. So 1 gallon is equal to 4.5 litres. What about 90 litres? How many gallons is that? So how many 4.5s fit into 90? Or what do we multiply 4.5 by to get 90? Now 4.5, if we double 4.5, that gives us 9. And then from 9 to 90, we can get by multiplying 9 by 10. So this is the same as multiplying 4.5 by 20. If this didn't make sense, don't worry. We can do 90 divided by 4.5. I'm going to write this in fraction format because we've got a decimal here. So by multiplying both numbers by 10 to get whole numbers, we'll get 900 divided by 45. So 90 divided by 4.5 is exactly the same as 900 divided by 45. So we did this so we can have whole numbers to work with. So now we can divide 900 by 45. So how many 45s fit into 90? That is 2 of them, exactly 2. How many 45s fit into 0? That is 0. So again, that gives us 20. That's just another way to work it out if the first one didn't make sense. So we know that we've multiplied 4.5 by 20 to get 90, so we'll do the same here. So 1 times 20 gives us 20 gallons. So there are 20 gallons of water in the tank. It says here that you can keep 2 small fish in the tank for every 1 gallon of water. So the ratio of fish to gallons of water is 2 to 1. Now there are 20 gallons of water. We need to put it under gallons of water, not here. So how do we get from 1 to 20? By multiplying 1 by 20. Doing the same here. 2 times 20, that is 40. So 40 small fish can fit in the tank. Matt thinks he can keep more than 36 small fish in the tank. Is Matt correct? We're going to say yes. He can keep 40. The radius of the top of the cylinder is 7 centimeters. What is the volume of the cylinder? To work out the volume of the cylinder, we need to work out the area of base and then multiply that by the height. So we know the height is 10 centimeters. We don't know what is the area of the base, which is circular. We're going to work it out. So the radius is 7 centimeters. To work out the area of a circle, we do pi r squared. So we're going to use pi equals 22 sevenths, and we'll multiply that by r squared. So radius is 7 squared. So 22 sevenths times 49 ones, that is. I noticed that these two numbers that we've got across, 7 and 49, I can simplify them, but only when they are across, like this. So we've got 7 divided by 7, which gives us 1, and 49 divided by 7, which gives us 7. So that makes the numbers easier to work with. So all we're doing now is 22 times 7. Seven times 2 is 14, so 4 down, 1 carried over. 7 times 2 again, 14, and the 1, that is 15. So that is 154 over 1, which means just 154. So that's the area of the base. We're going to multiply by the height, which is 10. So 154 times 10 gives us 1,540, just adding 0 at the end. Now here you could have multiplied 22 by 49 and then divided that by 7, which would give you the same answer in the end. I just recognized that 49 is a multiple of 7 and they were opposite each other like that, so I could simplify them. I could have done the same with 22 and 1 if they were in the times tables of a particular number, but that wasn't the case. A man has a fish tank with the following dimensions: 24 centimeters by 41 centimeters by 29 centimeters. He needs to know approximate volume of the tank. What is its approximate volume? So approximate means we've got to round the numbers before we calculate. So 41 centimeters, we can round that to 40. 29, we can round that to 30. 24, we can round that to 20. Even if you round it to 25, shouldn't make a difference in terms of the marks you get. So I'm going to do 20 times 30 times 40. So 20 times 30 first. 2 times 3 is 6. Adding the two zeros makes this 600. So 600 times 40 now. 6 times 4, 24. 1, 2, 3 zeros. So that is 24,000 cubic centimeters. The bank is ordering more leaflets. Leaflets are packaged in boxes like this. The boxes have to be stored in a cupboard. The base of the cupboard is 1.2 meters by 0.6 meters and it is 0.8 meters in height. What is the maximum number of boxes that can be stored in the cupboard? So we're looking to find the maximum number of boxes that can be stored in the cupboard. We've got the dimensions of the box, and that is 14 centimeters by 14 centimeters by 25 centimeters. And it says that this is the top of the box here, and boxes must be kept upright. Then we have the dimensions of the cupboard. I'm going to try and draw here as well. So 1.2 meters by 0.6 meters by 0.8 meters. So we've got different units. First thing to do is to convert the meters into centimeters. So 1.2 meters, that will be 120 centimeters, because there are 100 centimeters in a meter. 0.6 meters, that will be 60 centimeters, and 0.8 will be 80 centimeters. That is the height, 80 centimeters, and we've got the length here, 120 centimeters, and the width, 60 centimeters. So the length of the box is 14 centimeters. How many lots of 14 can we fit into 120? In other words, what is 120 divided by 14? So 14 and 14, that is 28. So 2 lots of 14 make 28. What about 4 lots of 14? That will be 28 and 28, which is 56. So we can keep going. 56 and 56. So that is 112. So that is 8 lots of 14 that make 112. We have 8 remaining, but there is no point in continuing because you can't have part of a box. So only 8 can fit along the length. What about along the width? So this is 60 centimeters and we've got 14 centimeters. So we'll do 60 divided by 14. So again, 14 and 14, that is 28. 28 and 28 gives us 56. So 4 lots of 14 gives us 56. We can't add any more. So that will be 56, and we have 4 remaining. Then again, just like in the previous one, there is no point in continuing because you can't have part of a box fit in. So that will be 4 fit in along the width, and height is 80 centimeters. So we'll do 80 divided by 25. 25 and 25, that is 50. 50 and 25 is 75. So 3 lots of 25 give us 75. That would be 5 remaining, but again, there is no point in continuing to work out the digits after the decimal point because we can't fit part of the box. So 3 along height. So if I show this, give you an idea how many boxes will fit. So if you think of this as having 3 levels going up, so there's 1, 2, 3. At the bottom, we've got 1, 2, 3, 4, 5, 6, 7, 8 times 1, 2, 3, 4. So 8 times 4, that is 32. And it's 3 levels, so we're doing 32 times 3. 3 times 2, that is 6. 3 times 3 is 9. So that is 96 boxes. Now we move into the calculator questions. Here is a cube of side length 2.5 centimeters. Work out the surface area of this cube. To work out the surface area, we just work out the area of each of the faces. So as you can see, there are 1, 2, 3, 4, 5, 6. 6 faces in a cube. So 6 times the area of each of these faces, which is identical. So we know the dimensions. We've got side length of 2.5 centimeters, which means that this is 2.5 centimeters as well, as this is a cube. So 2.5 times 2.5. That's how you get the area of each of these faces. So 6 times 2.5 times 2.5 gives us 37.5. A team of workers deliver identical fridges. The team will use the average time to fully load an old lorry to predict the time to fully load a new lorry. The table shows the times it took to fully load the old lorry with 24 fridges. The diagram shows the space available for fridges in the new lorry. The space is in the shape of a cuboid. Each fridge needs a rectangular floor space 1000 mm by 800 mm. The team do not stack fridges. They think it will take less than 90 minutes to fully load the new lorry. Are they correct? Okay, so first of all, let's work out the average time it took to load the old lorry. So 52 plus 60 plus 55 plus 59 plus 54 plus 63 plus 56 equals 399, divided now by 1, 2, 3, 4, 5, 6, 7, which is 57 minutes. That's the mean that we used. Now we've got the diagram which shows the space available for fridges in the new lorry, and we've got the dimensions: 13,600 millimeters by 2,400 millimeters. So let's work out how many fridges will fit along the length. So what we're going to do is 13,600 divided by 1,000. .6, which means 13 fridges will fit along the length. So you can imagine along the width. We'll work out by doing 2,400 divided by 800. It gives us 3. So that's 3 of them. And they do not stack fridges, so that's it. So imagine this. So 3 rows of 13 each. So 3 times 13 is 39. So 39 fridges. The old lorry took on average 57 minutes. So that was for 24 fridges. So what we're going to do is 57 divided by 24 to work out how long it takes for one fridge. Which is 2.375 minutes. So if we do 39 times 2.375, gives us 92.625. So this is greater than 90 minutes, not less. So are they correct? We're going to say no. It takes about 93 minutes. James has a contract to paint 30 identical water tanks. He has to paint the outside surfaces of each tank, but not the top. Each surface is rectangular. James knows that 1 tin of paint is enough to cover 12 square meters of surface. Costs £26.99. Work out the total cost of the tins of paint he will need for all 30 water tanks. Okay, so we've got the dimensions: 1.1 meters, 0.80 meters and 0.60 meters. So let's take each of the faces in turn. Looking at the front, to work out that area, we'll do 1.1 times 0.60, because that's what the height is equal to. So that gives us 0.66. And this face here on the back, that will be identical. So we can do 2 times 0.66, which is 1.32. So far. Now we've got the sides here, so it's 2 of them. So we'll do 2 times 0.80 times 0.60. So the area is worked out by multiplying 0.80 by 0.60. With a 2 in front, we can work out for both at the same time. That is 0.96. And one more to go. That's the base here. So we'll do 1.1 times 0.80. Which is 0.88. So we'll add these 3 now. That is 3.16. So that's the surface area to paint for one of them. But he's got 30 identical water tanks. So we're going to multiply this by 30. And that gives us 94.8 square meters. One tin covers 12 square meters, so we'll do 94.8 divided by 12, which is 7.9. So he needs 7.9 tins, but of course you can't buy part of a tin, so we're going to say 8 tins. So 8, and they cost £26.99 each. So 8 times 26.99 gives us £215 and 92 pence. And that's the total cost. Here is a diagram of a doll's house Jaden has made. 2 faces are each in the shape of a pentagon with a vertical line of symmetry. All of the faces are rectangular. The base angles of each pentagon are right angles. Jaden wants to cover all the surfaces of the doll's house with paint. He knows the total area of the base and the roof is 1.3824 square meters. Jaden has enough paint to cover 3.5 square meters. Has Jaden got enough paint to cover all the surfaces of the doll's house? Show why you think this. Okay, so we're given the area for the base and the roof, which is 1.3824 square meters. So we don't need to work those out. What we need to work out is the area of these two rectangles here at the front and at the back. They're identical, so we can work out one and then multiply it by 2. And we've got the two pentagons, so work out one and then multiply the area by 2, and then add the total. So let's start with the front here. So we've got the dimensions given to us. Length is 0.96 and height is 0.63. So times 0.63 gives us 0.6048 square meters. So the other side will be identical, and looking at the pentagon, so we're going to split that into two shapes, the rectangle and triangle. So rectangle, that will be 0.7 times 0.63. Which is 0.441, and that will be the same here. Now, the triangle, the base of the triangle is equal to 0.7, because these two lengths will be the same. So 0.7 meters, and the height we can work out because we are given that from this point to this point, this is equal to 0.75 meters. So 0.75 if I take away this, which is this length, this height here, that will be 0.63. Which is 0.12. So we know the height is 0.12. So to work out the area of the triangle, we'll do 0.7 times 0.12 divided by 2. Zero 0.042. So that's for the triangle here. And we've got another triangle over there. Now we'll add all of these. So 0.6048 plus 0.6048 plus 0.441 plus 0.441 plus 0.042 plus 0.042 gives us 2.1756 square meters. We shouldn't forget to add the base and the roof. So 2.1756 plus 1.042 3824. This is 3.558 square meters, which is greater than 3.5. So has Jayden got enough paint? I'm going to say no. The pool where Asha swims is rectangular. It is 2,500 centimeters long and 1,250 centimeters wide. The four sides of the swimming pool are 150 centimeters deep. They are covered with small square tiles of different colors. Each small tile has an area of 1 square centimeter. Asha thinks there must be over 1 million small tiles covering the sides of this pool. Is Asha correct? Explain how you decide. So we can start imagining the pool. It is 2,500 centimeters long and 1,250 centimeters wide. And we've got the depth of it, which is 150 centimeters. So these sides, we are covered in tiles. So these long sides, they measure 2,500 by 150, and we've got two of them. And these sides, they will measure 1,250 by 150. So using a calculator, I do 2 times 2,500 times 150, which is 750,000, and 2 times 1,250 times 150 is 375,000. That's square centimeters squared. So adding these together, because we've got four sides in total, 2 and the 2, gives us 1,125,000 centimeters squared. That's the total area, and each small tile has an area of 1 centimeter squared, so there are more than 1 million. So is Asha correct? We're going to say yes. The large pizzas are sold in cardboard boxes. When closed, the boxes measure 40 centimeters by 40 centimeters by 2.5 centimeters and are cuboid. This is the net of the pizza box. The company thinks it could use the same net but reduce the dimensions to 38 centimeters by 38 centimeters by 2 centimeters. Beth is asked to calculate the percentage reduction in cardboard if the smaller boxes are used. What answer should Beth get? Since it's the cardboard that they want to reduce, we're looking at surface area. So we've got the dimensions given. We've got two big squares that measure 40 centimeters by 40 centimeters. So to work out the area for those, we'll do 40 times 40. 4 times 4 is 16. Adding the two zeros gives us 1,600 centimeters squared. So that's the same here. Now we've got the sides and the flaps. So we've got this rectangle here, which is 40 centimeters by 2.5. Which is 100. So this is 100 as well. This is 100. This is 100. 100. 100. 100. 100. 100. So 2 lots of 1,600, that is 3,200. Adding these hundreds, we've got 1, 2, 3, 4, 5, 6, 7, 8 of them, 9, including this. So that is 3,200 plus 900, which is 4,100. Now they're reducing the dimensions to 38 by 38 by 2 centimeters. So what happens now? I'll start with the big squares. So that's going to be 38 times 38, which is 1,444. And we've got 2 of them. And then we've got these sides and the flaps. So each of them will be 38 times 2, which is 76. Now that is 9 of them, so 76 times 9 gives us 684. So adding all these together gives us 3,572. So what is the difference? $528. So that is 528 out of the original, which is 4,100. Gives us 0.128 as a decimal. Now, as a percentage, that will be 12.8%. It was 8, so 8.7. So we could do 8 here, so you can say 12.88%. Just added the last digit, rounded it to 2 decimal places for the percentage. So 12.88%. But even if you said 12.9% or 13% after showing the full working out as we did, should be absolutely fine. The pond will be a cuboid. It will be lined with a sheet of plastic pond liner. The pond liner covers the bottom and sides of the pond. The pond liner needs to be cut to this shape to exactly fit into the pond without any overlaps. The dimensions of the pond liner are shown in this diagram. So we've got 7.65 meters by 4.38 meters and got depth 0.72 meters. Sheets of pond liner are available in these sizes. We've got A, width, length and price, B, C, D and E, so dimensions for each of them. Aria needs to buy the cheapest pond liner that is big enough to fit the pond. Which pond liner should she buy? Show your working. Okay, so the actual length will be including the depth here. So we're going to need to add 0.72 on both sides to work out the length. So 7.65 plus 0.72 plus 0.72, which gives us 9.09 meters. And width, again, we're going to need to add both sides 0.72. So 4.38 plus 0.72 plus 0.72 gives us 5.82. So width 5.82. So from C onwards, so C, D and E would be long enough, or wide enough, I should say. Looking at length, 9.09. That should be okay to cover it, and D and E as well. So that would be the cheapest one, which is C. The group asked Aria to buy chemical treatment for the pond water to make it suitable for fish. One bottle contains enough chemical to treat 1,300 gallons of water. 1 cubic meter is equal to 220 gallons. Ariane adds water to the pond until it is 92% full. How many bottles of chemical treatment will she need? Show your working. Okay, so this question links to the previous one. So we've got to work out the volume of the pond. So we've got the dimensions. So 7.65, 4.38 and 0.72. So that is 24.12504. cubic meters. 1 cubic meter is equal to 220 gallons. What about 24.12504 cubic meters? So to get from 1 to 24.12504, we multiply by 24.12504. So we'll do the same here. And that gives us 5,307.5088 gallons, that is. So that's the full capacity of the pond. But Aria will add water to the pond until it's 92% full, so not 100%. This is the 100% capacity that we've got here. So what we're going to do is work out 92% of 5,307.5088 gallons. So it's like multiplying the number by 0.92, which gives us 4,882.908096. So that's how many gallons of water will be in the pond. One bottle of chemical treatment will treat 1,300 gallons of water. So how many of them do we need? So what we're going to do is 4,882.908096 divided by 1,300. Which is 3.756 bottles. Now, we can't buy part of the bottle, so we're going to say 4 bottles. Aria needs to work out how many fish can be put in the pond. She wants to have both koi fish and goldfish. The number of fish is based on the surface area of the water in the pond. Koi fish need 1.2 square meter each. Goldfish need 0.6 square meter each. Aria wants to have a mixture of koi fish and goldfish in the ratio 1:4. What is the maximum number of koi fish and goldfish that Aria can put in the pond if she keeps the ratio 1:4? So the surface area of the water in the pond is the area at the top of the pond. It's not like any surface area of any shape that you work out. In this particular case, it's a case of where water meets oxygen. So I'll go back to the dimensions. So if you imagine, this will be top of the pond, and that will be 7.65 by 4.38. Which is 33.507. So we given koi fish need 1.2 square meters, and goldfish needs 0.6 square meters. So if she keeps one koi fish, that will be 1.2 square meters, and 4 goldfish, that will be 4 times 0.6, which is 2.4. So that will be in total 3.6. She has 33.507 square meters. So how many times larger is that than 3.6? Well, we're going to divide it by 3.6 and it gives us 9.3075. So we'll multiply by that. Over here as well, square meters. So for one goldfish, and obviously you can't have part of a fish, so this will be times 9. So 9 times greater. So 1 times 9 gives us 9 koi fish, and 4 times 9, that is 36 goldfish. There is an oval pond in the allotment. The pond is 7 meters long, 5 meters wide and 80 centimeters deep. The pond is to be filled in with soil. The formula to find the volume in cubic meters of the pond is pi times L divided by 2 times W divided by 2 times T, where L is the length in meters, W is the width in meters, D is the depth in meters. Use pi equals 3.14. So we'll work out the volume of the pond. We've got pi that's been given to us being 3.14 times L, which is the length, and that is 7 meters. So 7 divided by 2. And then width is 5 meters times depth, which is 80 centimeters, but we got to give it in meters. So that is 0.8, which I should write in the middle. So using a calculator now, we'll do 3.14 times 3.5 times 2.5 times 0.8, which is 21.98 cubic meters. Soil can be bought in 2 sizes of bag. For A, volume of soil 0.9 cubic meters, price per bag £74. We've got B, volume of soil 1.5 cubic meters, price per bag £110. The pond should be filled as cheaply as possible. How much will it cost? Show you working. So we've got the volume that we worked out, which is 21.98 cubic meters. and we've got volume per bag for A, that is 0.9. So what we're going to do is 21.98 divided by 0.9, and that is 24.42. So 25 bags will be needed. 25 times 74 pounds gives us 1,850. Let's try with B. So 21.98 now divided by 1.5, which is 14.65. So that will be 15 bags times 110 pounds per bag. This is 1,650. The cheaper between the two is B. So I'm going to say B and 1,650 pounds. If 3 people work together, it would take them 8 hours to fill in the pond. How long would it take 5 people working at the same rate? So the ratio of people to hours is 3 to 8. If 5 people work at the same rate, how long would it take them to complete it? So the more people get involved, the less time it will take. So this is inverse proportion. What do we multiply 3 by to get to 5? So 5 divided by 3, which is 1.67. So I'm going to keep that as it is there. Now on this side, we'll do divide by 1.67. That's rounded to 2 decimal places because 6 is recurring. So 8 divided by 1.67 gives us 4.79. Now 4.79 hours, that was because we rounded 1.6 with the 6 recurring to 1.67. If we hadn't rounded, this would be 4.8 hours. Even if you write 4.79, should be absolutely fine. The cylinder has radius 1.5 meters and height 1.25 meters. Calculate the volume of the cylinder in cubic meters. Give your answer to 1 decimal place. Use pi equals 3.14. So we have a cylinder which has a radius of 1.5 meters and height 1.25 meters. To work out the volume, we work out the area of the base, which is a circle. So we use pi r squared, and then we multiply the answer with 1.25. So pi is 3.14 times the radius, which is 1.5, and then we're going to square it. Is a 7.065. square meters. Now, to work out the volume of the cylinder, we multiply 7.065 by 1.25. Which is 8.83125 cubic meters. We've got to give our answer to one decimal place, so this will be the cutoff point. Looking at the 3 means we've got to round down, so we're going to keep this as 8.8 cubic meters. Jan needs to cover a ball with glitter. The ball's radius is 60 centimeters. The formula to find the surface area of a sphere is A equals 4 times pi times radius squared. Jan buys the glitter in bottles. She needs to use 300 grams of glitter per square meter. Each bottle holds 254 grams of glitter. Calculate the number of bottles of glitter needed to cover the sphere. Show your working. Use pi equals 3.14. So we've got formula four times pi, which is 3.14, times the radius, which is 60 centimeters. But as we're going to later work with square meters, it makes sense to convert this now into meters. So this is 0.6 meters. So we're going to square that. So 4 times 3.14 times 0.6 times 0.6 gives us 4.5216 square meters is the surface area of the sphere. She needs to use 300 grams of glitter per square meter, and there are 4.5216 square meters, so we're going to multiply that by 300, which gives us 1,356.48 grams. Each bottle holds 254 grams, so we're going to divide 1,356.48 by 254. That gives us 5.34 bottles. So we're going to say 6 bottles, because we can't buy part of the bottle. One cubic meter is the same as 100 cubic centimeters, 1,000 cubic centimeters, 100,000 cubic centimeters, 1 million cubic centimeters. We've got to take the correct one, so I'm just going to quickly draw a cube. Side length is 1 meter. So I'm going to convert them into centimeters. 1 meter is 100 centimeters. So this is 100 centimeters as well, and this is 100 centimeters. To work out the volume, we do 100 times 100 times 100. So that gives us 1 million cubic centimeters. So option D is the correct one. 1 cubic meter is the same as 1 million cubic centimeters. A craftsman uses resin to make a paperweight. He makes the paperweight from two parts, a hemisphere and a cylinder. He uses this plan. How much resin does he need for both parts? Show all your work in. So we're going to work out the volume of both of the shapes. Let's start with a cylinder. Do we know the radius of the cylinder? We've got the being equal to 6 centimeters, so the radius is 3, half of that. So we're going to use that to work out the volume of the cylinder. So start with the area of the base, so pi r squared. We'll use 3.14 for pi times the radius, which I said was 3, so 3 squared, so 3.14 times 9, which is 28.26, and now we'll multiply this by height. So volume of the cylinder is 28.26 times the height, which is 5 centimeters. So times 5 gives us 141.3 cubic centimeters. Now let's work out the volume of the hemisphere. We've got the formula for it, which is V is equal to 2/3 of pi times radius cubed. Pi is 3.14 and radius is 3. So 2/3, that is 2 divided by 3, times 3.14 times 3 cubed, that is 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. So 56.52 cubic centimeters. So altogether that will be 56.52 plus 141.3. Which is 197.82. What is the volume of this triangular prism? We're given the formula. V is equal to V times H times L divided by 2. So V is for volume in cubic centimeters, B is for base in centimeters, H is for height in centimeters, and L is for length in centimeters. So let's just replace these. B is equal to 16 centimeters. So that is the base of the triangle. And then height, that is 6 centimeters, and length, that is 30. So all divided by 2. So 16 times 6 times 30 divided by 2 gives us 1,440 cubic centimeters. You send the photo frames in boxes, which you cover in paper. We've got a diagram which is not to scale, which means it doesn't have the actual measurements of the thing, and the dimensions are not in proportion. So we've got now 1 inch is equal to 2.54 centimeters. You need to calculate the surface area of the boxes in centimeters to find out how much paper you need to cover each box. As you need to include additional paper for the flaps, you use the following formula to calculate the total amount of paper required per box. S times 0.5 pi equals T. S is total surface area, T is total amount of paper required, pi is equal to 3.14. What is the total surface area of paper required per box? Give your answer in centimeters squared. Show your working out and write the answer in the box below.
So we'll work out the surface area first, so that we can get the total amount of paper required. So let's work out this face. So that is 20 inches times 6 inches. Let's convert them into centimeters. So 1 inch is 2.54 centimeters. What about 20 inches? So 1 times 20 gives us 20. So we'll do the same here. So that is 2.54 times 20, 50.8 centimeters. And then we've got 6 inches, so we'll do 2.54 times 6, which is 15.24 centimeters, and 12 inches, that will be double that, so we're just going to multiply it by 2. 30.48 centimeters. So going back to this first step of working out the area of this face, we'll do 50.8 times 15.24, which is 774.192. The other side here on the back will be identical, so we can add another 774.192. Let's look at this face. That has dimensions 30.48 and 15.24. So that's just 464.5152. And of course, this face here on the back is identical. We'll add another 464.5152. And top is the same as the base, so that will be 30.48 times 50.8. And that is 1548.384. That's 2 of them. So adding all of these together. Gives us 5,574.1824. That's the total surface area. So we need to multiply it by 0.5 lots of pi. Is 3.14. So times 0.5 times 3.14 gives us 8,751.466368. And that's the final answer. Your manager has asked you to unload some boxes from a delivery and put them in the storage yard. There are 3 different sized boxes. Which box has the largest volume? Show your working out and write the answer in the box below. So volume is worked out by multiplying length by width by height. So what we're going to do is multiply them and write them here. So for box A, that is 40 times 25 times 100 gives us 100,000 cubic centimeters. So I converted this into 100 centimeters. Now for box B, we'll do 35 times 30 times 80. So 84,000. And box C, we'll do 38 times 28 times 90, which is 95,760. So which of them has the largest volume? That is this one. That's box A. The delivery arrives on a pallet which contains 8 boxes, either A, B or C, from the table above. The pallet weighs 5 kilograms. For deliveries up to 30 kilograms, use a trolley. For deliveries over 30 kilograms, use a forklift. Using the table above, will you use a trolley or the forklift to unload the delivery? Show your working out and write the answer in the box below. So this links to the previous question. We don't know which of the boxes will be delivered, but we know it's going to be 8 of them. And let's just consider the lightest of the boxes, lightest in weight. So we've got 2.6 kilograms here. So if that is the case and box C, so 8 lots of box C are delivered, then we'll have 8 times 2.6 kilograms. And that is 20.8 kilograms. Add to this the weight of the pallet, which is 5 kilograms. Then we have 25.8 kilograms, which is up to 30 kilograms. So that suggests using a trolley. What if the heaviest boxes are delivered. So that would be 3.1 kilograms each. So we'll do 8 times 3.1. Gives us 24.8. Add 5 to that, gives us 29.8 kilograms, which again is within 30, so up to 30. So we're going to say trolley. Because in all eventualities, they will need to use a trolley. You need to have a total of 1000 liters of water available for your animals. You use troughs to hold the water. The ends of the troughs are semicircles. You use the following formula to calculate the volume of water each trough will hold. V is equal to pi r squared times L, all divided by 2, where V is volume of water in cubic centimeters, R is radius of cross-section in centimeters, L is length of trough in centimeters. Use pi equals 3.14, 1 liter is equal to 1000 cubic centimeters. You have estimated that one trough is approximately a fifth of the 1000 liters of water you need. Are you correct? Show your working out and write the answer in the box below. So we've got the formula given to us. So V is equal to pi is 3.14 times the radius squared. So what is the radius? The diameter is 38 centimeters, so the radius is half of that, which is going to be 19. So 19 squared times L, which is the length. It's 1.8 meters, which is 180 centimeters. So all divided by 2. So 3.14 times 19 times 19 times 180 gives us this number, 204,037.2. Divide that by 2 gives us 102,018.6 cubic centimeters. So 1 liter is equal to 1000 cubic centimeters. What about 102,018.6? So we'll do 102,018.6 divided by 1000, which is 102.0186. So same thing here. The 1 times that number gives us the number itself, so that is 102.0186 liters. You have estimated that one trough is approximately a fifth of the 1000 liters of water you need. So 1/5 of 1000, that is 1000 divided by 5, which is 200 liters. Because this is 102 liters. So are we correct? Gonna say no. And we've shown the working out. We've shown why. Rahima finds that she can be more environmentally friendly by collecting rainwater from her drain pipe so she can use it to water her garden. Rahima buys a cylindrical container that is 80 centimeters in diameter and 1 meter high. So this is 1 meter high and diameter is 80 centimeters. Rahima thinks the container will hold at least 100 gallons of water. Is she correct? Pi equals 3.14. 1 cubic meter is equal to 219.97 gallons. Show your calculations and their workings out here. Let's work out the volume first in cubic meters. So that will be the area of the circle first that we need to work out, the base. Pi r squared. So pi is 3.14 and the radius, that is 40 centimeters. I'm going to convert it into meters since we're going to work with cubic meters later. So that will be 0.4 squared. So 3.14 times 0.4 times 0.4 gives us 0.5024. Square meters, that is the area of the base. So we're going to multiply it now by the height. So 0.5024 times 1, that is 1 meter. So that gives us 0.5024 cubic meters. So we're given that 1 cubic meter is equal to 219.97 gallons. What about 0.5024 cubic meters? So to get from 1 to 0.5024, we multiply by 0.5024. So we'll do the same here. Times 219.97. So that gives us 110.512928 gallons. And that is more than 100 gallons of water. So is she correct? We're going to say yes. The other thing we could have done here is that we've seen it's 0.5024, so that is just over 0.5, which is half. So half of 200, about 220, that's going to be 110, which is over 100. So that would have given us the answer as well. Now we've got to explain our answer in here, so what we can say is yes, the container holds just over 110 gallons. About 0.5 cubic meters. Maya runs a company that makes and sells candles. The mass of wax in grams needed to make a candle can be worked out using W equals V times 100 minus F all over 100 times 0.83. W is the mass of wax in grams, V is the volume of the candle in cubic centimeters, F is the percentage of fragrance in the candle.
The company makes the candle in the shape of a cylinder. The candle has radius 4 centimeters and height 15 centimeters. The candle has 10% fragrance. Work out the mass of wax in kilograms required to make 2,500 of these candles. So we'll use the formula, but we need the volume in cubic centimeters. So candle has radius 4 centimeters and height 15 centimeters. So pi r squared first to get the area of the base. So 3.14 times 4 squared. So that is 3.14 times 16, which is 50.24. And now we'll multiply it with the height. So get the volume. We'll do 50.24 times 15. Which is 753.6 cubic centimeters. Now we'll plug this into the formula. So W is equal to volume, which is 753.6 times 100 minus F, which is the percentage of fragrance in the candle. So that is 10%, so minus 10 divided by 100 times 0.83. So that will be 753.6 times 100 minus 10, that is 90. So 90 divided by 100 times 0.83. Divided by 100, that is 0.9. So using a calculator, now we'll do 753.6 times 0.9 times 0.83, which is 562.9392. That is the mass of wax in grams. So if I divide this by 1000, it will give me the mass of wax in kilograms. So that is 0.5629392 kilograms. The question asked to work out the mass of 2,500 candles. So we'll do 2,500 times 0.5629392. Which is 1,407.348 kilograms. A tin 4 carats is a cylinder with radius 2.8 centimeters and height 9 centimeters. When filled, 1/6 of the volume of the tin of carats is water. The company uses 425 liters of water each day in tins of carats. 1 liter is equal to 1,000 cubic centimeters. How many tins of carats does the company make each day? So we've got to work out the volume of the cylinder and then work out how many liters in the tin. So to work out the volume, we'll need to work out the area of the base, which is pi r squared. So 3.14 times 2.8 squared. Which is
24.6176. So we'll multiply that by the height to work out the volume. Which gives us 221.5584 cubic centimeters. 1 liter is equal to 1000 cubic centimeters. What about 221.5584 cubic centimeters? So what do we multiply 1000 by to get to this number? So we're going to do 221.5584 divided by 1000, which is 0.2215584. So we'll do the same on the other side. So 1 times that number gives us the number itself, which is 0.2215584 litres. So that's how many litres there are in 1 tin. That includes water, but it's not all water. Only 1/6 of it is water. So what we're going to do is we're going to divide this by 6. 0.2215584 divided by 6, which is 0.0369264. So if we divide 425 by this number, it should give us how many tins the company makes each day. So 425 divided by 0.0369264, which is 11,509.38. So we can say 11,509. That's why we can't round it up to 11,510. A cuboid is shown below because there isn't enough water to make the last one as well. Work out the total surface area of the cuboid. So surface area, that's adding all of the areas of the different faces. So looking at this one here, that will be 5 times 2, which is 10. And then this one here on the back will be 10 as well. And this one we can work out by doing 4 times 2, which gives us 8. And of course this one here will be 8 as well. And top one we can work out by doing 4 times 5, which is 20. And then the base as well will be the same. So adding all of these together, 10 and 10, which is 20, and the 8 is 28, and the 8 and 20 and 20 gives us 76. A cylinder has radius 3.2 centimeters and height 7.5 centimeters. Work out the volume of the cylinder. So area of the base first, which is pi r squared. So pi 3.14 times the radius, which is 3.2. So that will be squared. So 3.14 times 3.2 times 3.2 gives us 32.1536. Now, to work out the volume, we'll multiply 32.1536 by 7.5, and that is 241.152 cubic centimeters. Molly is building a conservatory. Here is a plan view of the conservatory. Plan view, that is looking at it from the top. The conservatory floor will be made of concrete. The concrete floor will be 0.1 meters deep. What volume of concrete will Molly need for the floor? State the units of your answer. So this is a compound shape. It's made of different shapes, different simple shapes. I'm going to split it here and then here as well. So if I work out the area, then I can multiply it by the depth to get the volume. So this one here will be 4 times 3, which is 12. This rectangle here will be 3.4 times this length here, which I can work out by doing 4.5 take away 3. So that will give me 1.5. So 3.4 times 1.5 gives us the area for that rectangle. So 3.4 times 1.5 is 5.1. And now we need to work out the area of the triangle. The base, that is equal to 4 take away this length here, which is 3.4. So that is 0.6 meters, and the height we worked out earlier, so that was 1.5. So what we're going to do is 1.5 times 0.6 divided by 2. .45. So adding 0.45 and 12 and 5.1, get 5 here, 5, 7, 1. So 17.55 square meters. We need to multiply that by 0.1 to get the volume.
So 1.755 cubic meters. And that's the end of the questions.